Hello everyone. In today's video, I'm going to teach you how to implement chi-square formula and use that in order to test our DI that we made in last video to see if it's completely fair or not. I'll start by creating a C file called chi.c. Then include the standard input and output libraries. Then define some integers for number of sides and number of times that we are going to roll the die. Then some floating point numbers for expected value, observed value, and total. And sum of total. So number of sides, number of times, expected value, observed value, sum of values. Then we need to get number of sites and number of times from user input, and then get the each observed value for each site in the die. So the expected value must be the result of number of times divided by number of sides on the die. So then we need to get number of observed times for each side in a loop in iteration. So let's define that. I add an integer called loop counter. Loop counter in order to make a loop. Sides LC plus enter the number times side was row, which is LC. Scan long float, which is the observed value. So value. Then here's the main part. Sum of the values must be added to the chi-square must be added to the sum of values, so we can get the result this way. So observed value minus expected value powered by 2 powered into that number is a square. Divided by expected value. Then print the sum of values and close the program. The chi-square is a correct way to spell a square. What? Square for the total chi-square. Chi-square is a long float. Sum of values. And return 0. Yes. Compile the program. So let's resort the test file to see if it's completely fair or not. Test count unique sites, and the number was probably 360 last time. Let's run the program. Number of sites on the day 6, 360. Oh, there was +1 that I forgot to put there. 68, 58, 68, 61, 53, and 52. Total of s square is 4.1. So the degree of freedom is sides not -1, so we have 5 degrees of freedom, and we need to check that in chi-square table. Okay, from statistics-howto.com. So 5 degrees of freedom, and that's somewhere between 50 to 60%. That's a good value in order to, and that shows that the die is mostly not biased. The numbers aren't related and they are purely random. Let's do the test again. But before that, let's do some change to main file. So here, add a new line, add 1 to the LC. Usual dice do not contain number 0. Compare it again. And that's it. So roll the die for 60 times and push it in test. And 6, 60, 12, 7, 9, 11, 11, 10 is 1.6. So this time it says 90%. The numbers are irrelated, not related. One thing to note is that for bigger numbers, the p-value, the percent we are getting here, is usually meaningless. So we need to consider that for a very big data set from our die, the numbers may start making sense, but that's not in a way that matters. So that was it. The source file I will put the source file in the GitHub and link it in the description of this video. And don't forget to like and subscribe. Thanks.